Alright, so very quickly, we want to handle this. We want to deal with this, and then, of course, we have actually done a lot of things already based on differentiation. Say differentiation to also be equal that will change in y if I will change in x. So change in y depending on the change in what x, right? So the result of particular function is change, the change. It's a slight change. Where the change happens, no what good or all right. So say this is what we use with the note of uh what we use to denote differentiation, right? X. So if I have maybe y to be x is to power n, right? So if I want to differentiate this number, that means this y value, the x is to power n followed by the x. Remember, depending on x now here. So I'm going to have this n can come down x, and then we did this one by one. Okay. So we said that only is what we called general formula, right? General rule for differentiation. We call it general rule for differentiation. So just take note of that. Like it's somewhere in your paper. All right. So we have this. If I want to differentiate two things and they are adding themselves, right? We want to differentiate a product of addition, right? Addition of soon different. We have 2x squared plus 5. Something like you already have a function like this, and I want to differentiate. Of course, I'm going you can change the individual, but I'm going to differentiate the individual. Whatever I get as the individual, the decision becomes my answer. Like I'll put them together as the answer. How to do that? So this is what I need. So what we have there. You have to find Vy Vx, right? We have to differentiate this 2x to power 2 minus 5x to power 3 plus 2 all of our ax. Remember, we're not using the first principle, but that will take us a lot of time. Using the first principle is going to take us a whole lot of time. So that is why basically many times we don't use it, especially the JAMB bites. You basically don't need the first principle in that sense, but you need to understand how the first principle works. Is very important for later use, right? So remember, mathematics is always progressive. So that's what you can take note of. Mathematics is progressive. Move from one stage to the other. So now look at Alex. What am I going to do here? More differentiated guy. Remember, I was saying this till it comes down. Okay, I'm gonna have 2 till it coming down. Then I have x 3 minus 1, right? Minus these 2 come down 5, 2 coming down, and I have x 2 minus 1. So these two, whenever I differentiate the constant, I'm going to get what? 0. Of course, this thing means 2, 0, x 0 minus 1. Of course, 0 times 2 is 0, right? Times x is 0. So there's no need. That's why they said if I differentiate a constant, I'm going to get what? 0. I believe that's clear now. Every constant is anything to the power 0 is what? 1. So x to the power 0 is 1. 1 times 2. So there was this constant here. So basically, he's simply telling us that if I'm differentiating this guy, this 0 is going to come down here. I'm going to have 2 times 0, right? And then x 0 minus 1. So of course, which we result towards 0. Okay, so we have 6x squared. 3 minus 1 is 2 minus 10x is to power 1, right? So it becomes my answer. So in the y dx becomes this. I differentiate y, we'll expect to x. You're going to have something like this. And have the second one. Dx raised to power t plus 1, right? So X. What am I going to do? And you can click for the differentiate now. I can change this one. Now I have 1 over x. 1 over 10 is the same thing as 0.1. Right? Am I correct? Quickly stereo to power minus 1. Isn't it? 1 over 10. 1 over 10 is center about 10 to power minus 1. So 1 over x will be what x is to power minus 1. So hope that makes sense. So I'm not going to have these two coming down. I have 3, 2, x, 2 minus 1. Whoops. Is minus 1 then copy here. I have minus 1x minus 1 minus 1. Well, so this is going to have 6x. Is minus already. So minus reacts with plus. You what was minus x minus 2. Right? So x minus 1 minus 1. Go you 1. Go you 1. Go you the total of 2. That is only 2. So I'm going to have, I can rewrite this as 6x minus 1 over x squared. Right? X minus 1 is what? 1 over x. X minus 2 is what? 1 over x squared. Right? Just take this guy down. 1 over. Right? Come the denominator. It does start that works.